Okay, this is Earth Science Chapter 25 for Mr. Fedeli. This is the worksheet 25.1. So you should have this worksheet for the beginning of the video. I'm not going to be able to keep it up on the screen. I'm going to be going through the chapter, but if you have this with you, you could be working through it. Okay? So here's the page numbers where you can find everything. A lot of it's in bold, so it should be pretty easy to find. Okay? Okay, so we're looking at number 1, Maria. I'm not sure if that's how it's pronounced or Maria, but I'm saying Maria. Okay, so it says describe each listed lunar feature, including how it formed. Where possible, describe the type and relative lunar age of any rock the features contain. So if you turn to 558, you'll see in bold, actually it tells you how to pronounce it, Maria. Okay? So it says the dark areas are great basins and level plains formed when lava spewed up to the surface through the fractures made by earlier giant impacts. Okay? So these are the Maria. Okay? Let's see if, yeah, I have it right here. Okay? So you can see that right there. Right? The next one is Mascones. Let's see if I'm pronouncing that one right. It doesn't show me how to say that one. Okay. So on this one, a little bit further down, we have some lunar geologists suspect that the denser material from deep inside the moon, the same type of material that spewed up to create a Mare basin, solidified within the fractures at a fairly shallow depth beneath the surface. These areas of high gravity are called mascones, short for mass concentration. Okay, number 3, ryle. Okay, ryles are trench-like valleys running through Maria bedrock. Okay, so you have that. Lunar highlands. Next page, okay? The lunar highlands appear brighter than the Maria because their rocks are lighter in color. And are a few mountain ranges and many craters. Okay, they lie at the edges of the Maria. The range includes the lunar Alps. I don't know if you need to know all of that. It says the mountains tower as high as 5 kilometers, over 13 times the height of the Empire State Building. Okay, let's go to lunar craters. Okay. So lunar craters are circular hollows on the moon's surface, formed by the impact of meteoroid strikes. The smallest craters are microscopic pits, but the largest, the Aitken Basin, is nearly 2,100 kilometers across. Scientists think that this basin formed when a large object, such as an asteroid or meteoroid, collided with the moon. Okay. Now, number 1, after you read, it says, compare the moon to Earth in terms of density, mass, diameter, and gravitational pull. Okay. Okay, so let's open this up. Properties and features of the moon. So the moon's diameter is 3,476 kilometers or more than 1/4 Earth's diameter. The moon's mass is only about 1/8 Earth's mass, and the density of the moon, about 3.3 grams per cubic centimeter, is lower than Earth's. Okay, Number 2, explain the impact theory and how the moon developed after impact. Okay. Okay, it says, let's see, let's go to this side. So we have, let's see. This theory proposes that the moon formed about 4.5 billion years ago as a result of a collision between Earth and a planet-sized object. Okay, so that's it for that worksheet, okay? Let's look at the review questions real quick. Okay, so according to the most widely accepted theory, what event led to the formation of the moon? Okay, so let's go. Let's see what I have here for a second. Okay, so what led to the formation of the moon? I believe it's back here. Okay, so the origins of the moon. What led to the formations of the moon? Okay, so this theory proposes that the moon formed about 4.5 billion years ago as a result of a collision between Earth and a planet-sized object. So the formation of the moon is the impact theory. Okay? Okay, give me just a second. I'm a little lost. Okay, there we go. Okay. What factors might affect the length of the rays formed after impact? Okay, so if you look at page 560, you'll see that rays is in bold, okay? Right here, okay? So you have rays radiate from a number of craters. Some rays appear to be hundreds of kilometers long. For a long time, their origin was a mystery. Recent evidence suggests that rays consist of shattered rock and dust that were splashed out by the meteoroids that formed the craters. Okay, so let's go to critical thinking. How does the size of the moon's core support the impact theory of the moon's formation? Okay. Okay, so we got to go back a little bit. One more, I think. Okay. So, properties and features of the moon. At the bottom of the paragraph, it says the moon's lower density supports the impact theory, whereby the moon would have formed from the less dense material from the outer layers of early Earth and the objects that had impacted it. Okay, number 4. Materials such as water that become gaseous easily at room temperature are called volatiles. How does the complete lack of volatiles in lunar rocks support the impact theory of the moon's formation? So let's see. So it says lunar soil is not really soil. Scientists prefer to call it regolith, which means loose rock material. It is grayish brown mixture of small rock pieces and fine particles that range in size from sand grains to fine dust. Unlike Earth soil, it does not contain any water. Regolith is formed by the smashing impact of meteoroids of all sizes. When large meteoroids explode, they mix rock fragments over broad areas. This stirring of regolith is called gardening. So if we go back to our question, how does the complete lack of volatiles or water in lunar rocks support the impact theory of the moon's formation? So we say that the moon was impacted, the Earth is hit off center by a planet-sized object. The impact heats and deforms both bodies. Some rocky debris remain in orbit around Earth. The debris ring, comprised of rocks from lighter, outer layers of Earth, and the impactor gradually coalesce, forming the moon. So, if there was more water or pressure, maybe that would have gone out into the atmosphere. Okay? Maybe even creating a different type of atmosphere. Okay, so that is 25.1. For 25.2, I'll show you the worksheet real quick. Oops. There she is. Okay, the moon's motion. So again, you're going to need to get this worksheet. Okay, so go ahead and get that worksheet. I'm going to pull mine up on my Chromebook here if I can. Okay, so I see before you read in your science notebook, write down what you know. Okay, we don't need to do that. All right, while you read, in the spaces provided, write a brief description of the moon at each phase. What will people on Earth see? What conditions cause this? So you need to look at page 563, okay? And if you look at this one, you're going to be able to describe with a brief description of the moon, and then also what it looks like, okay? What conditions cause this, all right? Okay, so after you read, compare a lunar eclipse with a solar eclipse. Discuss both cause and frequency. So let's see. So we have let's see, solar eclipse on page 564. So a solar eclipse occurs there we go. So a solar eclipse occurs when the moon comes between the sun and Earth and the moon's shadow hits Earth's surface. Then a lunar eclipse is an event during which Earth's shadow prevents the sunlight from reaching the moon. A lunar eclipse can occur only at the full moon phase. Even though a full moon occurs every month, a lunar eclipse occurs less often. The moon usually remains visible but has a dusky red or coppery color. Okay, number 2. List factors in the moon's orbit that affect its rotation or affect its motion. So that's 562 in your text. Okay, let's see if I can make it a little bit bigger. Okay, so Earth must rotate an extra 13 degrees more each day for a point on its surface to be roughly under the moon again. Since the Earth takes about 50 minutes to spin 13 degrees, the moon rises about 50 minutes later each day and sets about 50 minutes later as well. The moon's orbit around Earth is elliptical. When the moon is nearest Earth, it is said to be at perigee. When farthest from the Earth, it is at apocryphy. Okay? So that is your worksheet. Okay? These are review questions. Why does the moon rise at a different time each day or night? What is the difference between a partial and total lunar eclipse? What is the difference between an annular and a total solar eclipse? Critical thinking. How many days would you expect to fall between the new moon and the first quarter, the last quarter? Okay, and the last one is a paired activity that I don't believe you need to do. Okay, so number one, let's see. Why does the moon rise at a different time each day or night? Okay, let's see, 1 second. Okay, let me skip that one. Oh no, I found it. Okay, sorry about that. Okay, page 564. Okay. No, I didn't. Okay, let's just skip it. Okay. Number two, what is the difference between a partial and total lunar eclipse? Okay, so now we are on 564. Okay. And it is right here. Okay. A total lunar eclipse occurs when the moon is fully within Earth's umbra. A partial lunar eclipse occurs when only a portion of the moon is in Earth's umbra. On average, at least one total lunar eclipse occurs every year. If the moon travels through the center of the umbra, a total lunar eclipse may last as long as 2 hours. Okay. What is the difference between a partial and total lunar eclipse? We just did that one. Okay. What is the difference between an annular and total solar eclipse? Okay, so if you look at page 565, that's not it. Hold on 1 second. Too far. Okay, I thought I had it on here, but I guess I don't. No, I don't. Okay, that's all right. Okay, so you're going to want to look at page 565, okay? So what is the difference between an annular and a total solar eclipse? There's a picture, it says solar eclipse on it, okay? It says that an annular eclipse is when the moon is at apogee, its umbra fails to reach Earth as seen from the Earth. The moon's disk is slightly smaller than the sun's. It's the bottom picture. There's 3 suns. It's the bottom sun. Okay? The total solar eclipse is the first one. And it says that a total solar eclipse at perigee, when the moon is closest in its orbit to Earth. Areas of Earth within the moon's umbra experience a total solar eclipse. Okay, critical thinking. How many days would you expect to fall between the new moon and the first quarter and the last quarter? Okay, so if you look at, let's go back here. Okay, so if you look at let's just look at new moon to full moon. Okay, so find new moon and full moon. That's 14 days. Okay, so if we're going to be asked to move just a portion of that, what would that be? So you would be dividing, right? So new moon, the first quarter would be 7 days, okay? Because you're cutting that in half. Okay. So, and then it asks the last quarter. So, again, if you're going from the new moon and you want to go all the way to the first quarter, so you're going to find that. Okay. And then we said that was 7 days. And then to the last quarter, because it's the arrows are going one way, so that would be 7 plus 7 plus 7. Okay, so 7 times 3 is 21. Okay, so we have our section review and we have our worksheet done. Now we have 25.2. Okay, I'm going to show you this because you can look at this quickly if you were unable to follow some of what I went over, okay? So I'll leave this up for a second so you could write those page numbers down. Oh, okay, and we did skip number 1, didn't we? Let me go to 562. So why does the moon rise at a different time each day or night? Okay, so that's under the moon's orbit, okay, on page 562. The moon rises in the east and sets in the west, like the sun's rising and setting. This motion is apparent. It's really a result of Earth's turning on its axis. But unlike the sun, the moon is in orbit around the Earth, taking about 27 and a third days to complete each orbit. Okay? All right, so that's for that. Okay, so part of your assignment is you need to do, at the end of the chapter, there is a chapter review, okay? It's on page 568. Okay, so number 1 says, the daily changes in the moon's appearance are called the blank of the moon. Okay, so you're going to look at that. What are the daily changes? What do we call it? The moon what? Okay, so I want you to look at the second set of key vocabulary. Okay, and you should be able to figure out what those are. When the moon changes, what do we call that? Okay, and it's vocabulary, so it's going to be in bold. Long trench-like valleys running through the bedrock of lunar Maria are called. Okay, you might not remember we did mention Maria before, but if you look on page 558, you will find in bold your answer, okay? And that is going to be in your first set of key vocabulary. For number 3, the Aitken Basin on the moon is the largest known blank in the solar system. What do we call a big gaping hole? Okay, so look at your first key vocabulary terms on page 559. And then number 4, craters form after blank strike the surface of the moon. What hits the surface of the moon? Or what could hit the surface of the moon? Okay, and cause a crater. Okay, so you're going to be looking at your first set of key vocabulary. So you should be able to pick that out. And then number 5, a total solar eclipse occurs when the tip of the moon's blank reaches Earth at perigee. Okay, so remember we were looking at that. That was one of the questions about total solar eclipse. and that is on page 565. Okay? Okay, let me make this a little bit bigger. What theory do most scientists think best explains the formation of the moon? Okay, so we discussed this a bit. It's on page 556. It was a review question, related review question on 25.1, number 1. Okay? How do lunar Maria differ from lunar highlands? So we talked about that. It's on page 558 and 559. Okay? Number 8. What evidence do scientists have of past volcanic activity on the moon? So on page 559, the second to the last paragraph, you'll find your answer there, okay? 9. How does lunar soil or regolith differ from the soil found on Earth? Remember, we talked about that. That was a question about water, okay? So go to page 560, reread that on regolith, which is in bold, okay? Number 10, describe how the moon's appearance to an observer on Earth changes during the course of a month. So number 10, page 563, think of the moon phases, okay? How does it look different throughout the month, okay? 11, explain how a lunar eclipse differs from a solar eclipse. Again, you can look at that picture and it will tell you. They're both vocabulary words and they're in bold. And it's on page 564. Number 12, the graphic organizer. Okay. It says copy and complete the concept map below. So the moon's features. We have Maria and we have 2 other things. Okay. And if you look back over here, it asks you a question. On number 7, it says, how do lunar Marias differ from lunar highlands, right? So, most likely, one of these is going to be lunar highlands, right? And then if you go to the next page, you're going to find the next thing, okay? So, Marias are made of what? So you'll have to go and look. The highlands are formed, or not formed, which are perhaps light colored. And then the other thing are formed by meteoroids, right? So you're going to find all of this on pages 558 through 560. So you would answer, what are moon features? So one of them they gave to you is Maria. Maria is made of blank. Blank are light colored. The other thing that the moon is made of are the features. And then which ones are formed by meteoroids, okay? Okay, so let's go to number 13. Write a statement suggesting how solar and lunar eclipses would be affected if the moon and Earth kept their present sizes and separation, but were 5 times farther from the sun at about the orbit of Jupiter. Whoops. Okay. So I have a hint. Look at page 564. Solar and lunar eclipses would be affected by, and then you can read and find out. Okay. 14. Write an explanation of the importance of the 5-degree difference in the orbital planes of the moon and Earth. So for that one, number 14, page 562, Moon's orbit. Under Moon's orbit, the heading, the 5-degree difference is important because, and then you can write about that. 15. Could an astronomer stationed in a moon base observe a meteor shower? Explain your reasoning. So think about the moon's atmosphere, okay? How would that affect your ability to see a meteor shower? All right, number 16. Evidence indicates that the moon and Earth formed at about the same time. However, rocks found on the moon are older than rocks found on Earth. How could you account for this apparently conflicting evidence? You're going to look at page 559 and think, could the moon be made up of something besides just the Earth's outer layer? Okay. So now we're to 17. It says, cover the times when waxing quarter phase cannot be seen. So the waxing is to your left, okay? So you see the waxing? So if you placed a piece of paper on your left covering up half of that earth, okay? At what time is the waxing quarter at its highest point? Okay, so you're looking at the waxing quarter. Okay, so there's a time by the waxing quarter. Okay, so that's the time you want to put. What time does it rise? Okay, so this is a little bit trickier. Okay, so for this one, you have to look at the times that are by the new moon and the full moon. Okay, so there's times by the new moon and the full moon. Okay, number 18. Determine the time of moonrise and moonset for the waning Gibson phase. So let's find that, waning Gibson. So waning Gibson is at the top to the right, and it's asking us again, time of moonrise and moonset. So it's at its highest point at 3 a.m. So I'm going to move over to my left 2 times to the waning crescent, 9 a.m. Okay, and then go back to where I was before at 3 a.m. and then move over from there 2 times to 9 p.m. So it's a shifting 2 times. Okay, I get a little confused which one is the setting and the rising, but it's kind of the opposite of what you would think. The rising is the nighttime, and the setting is the morning time. Okay? All right. 19. When the waning crescent phase is at its highest point, what time is it? Okay, so let's find that waning crescent phase. All right, I don't see it. Okay, now I do. So it's straight up to your left, waning crescent. So I think it's just the time, 9 a.m. I'm pointing to, I think. Okay, 20. Which phases could never be seen at 3 p.m.? So let us see. Which phases could never be seen at 3 p.m.? Well, we know that waxing crescent could. That one's I'm just not sure about. Okay, so not quite 100% how that all works. But anyway, this is it for the let's see. Yeah. Oh, no, we have 21. Okay, when the waning quarter phase is midway, so find waning quarter. Okay, that's straight up. So when the waning quarter phase is midway between moonrise and its highest point, what time is it? So we know its highest time is 6 a.m. Okay. And midway between moonrise is going to, I think, go to the left. So 9 a.m. is a guess. Okay, so obviously I'm not very good at interpreting this diagram. You might be able to go back and read. If not, you can always go on Google and search up some of this so you can understand it a little bit better. I'm sorry I couldn't help you more with this diagram. So this is Fidelity chapter 25. If you have any questions about it, please email me, text me, call me. In the next video, chapter 26, I'll see if I can clarify or be able to understand better this diagram so I could do a better job explaining it to you. Okay? So have a good day or evening, and I'll talk to you soon. Bye.